Before starting the construction of their house, most people pay special attention to the walls of the house. I will tell you later what most people are mistaken about, but there is a grain of truth in these thoughts. Even on my channel, videos about all stages of construction have gained 100 or 200,000 views, while the one about walls has almost a million. And when someone asks us what you built your house from, everyone always names the wall material, even though there is a lot more in the house. I tell everyone I built my house with aerated concrete blocks, but is that really true? It depends on how you count it. If you sort the estimate by the volume of materials used, then yes, most of the cubic meters in my house are aerated concrete blocks. Then come the insulation materials, then concrete, and then everything else. If you sort by tons, concrete is first, followed by aerated concrete blocks, then plaster with porcelain stoneware and others. Still, aerated concrete blocks are always near the top. In the case of frame houses especially, God forbid if they're on screw piles, no matter how you count it, it turns out that it's not a wooden house as many people think, but actually a house made of insulation in a plastic bag. I was recently in a good frame house on a slab, and yes, I was pleasantly surprised by the quality of the house, but that's a completely different story. Here's a secret, there was going to be a video called "To Hell with Frame Houses," but it won't be released. I finally get why they exist. And I don't think I've mentioned this anywhere before, but actually I originally planned to build a frame house for myself too, mostly because it was going to be my first time building anything in my life. I had already worked with sticks and insulation by myself before, but I had never dealt with all this pouring and aerated concrete blocks. I was just afraid I wouldn't be able to handle it. But as I got deeper into the topic of frame houses, I realized that I absolutely didn't want a house like that for myself, and I got further confirmation of this while building the attic in my house, since it's a typical frame structure. And then one pleasant summer day while walking through the forest, it suddenly occurred to me that all these timber frame setups on screw piles make sense, but only when there's no way for a concrete mixer or a truck with aerated concrete blocks to get through. When your vehicle simply gets stuck and can't reach the site, or all the aerated concrete blocks just break apart on the way, or you live somewhere where there just aren't any aerated concrete factories nearby. In other cases where these technologies are used without necessity, I think it's all about marketing tricks that take advantage of people's desire to save money. And here's where the main misconception lies. Everyone understands that the walls of a house are one of its most important parts, even if it's just on some subconscious level. It's not for nothing that I showed the view statistics for the videos. But personally, and I think many people as well, until I built my own house and dug into the budget analysis, I couldn't even imagine that the walls, such an important part, made up only 5% of the total construction costs for my house. This is something that really needs to be said again. The cost of the house's walls was only 5% of the total expenses, and any attempts to save money on the walls would only amount to fractions of a percent. And at least in my mind, before I started building, there was a logical chain. If the walls of the house are the biggest and most important part, and if I save money on them, then I'll get the greatest savings. And this is the main misconception, which I happened not to fall for purely by chance. Honestly, I did fall for it a bit. I used 300 by 300 D300 aerated concrete blocks for the walls instead of 400 by 400 D400. But I had a complicated situation after the fire, and under those circumstances, even a 300 block seemed like a luxury. But under normal life circumstances, if I were to build again, I would consider the thickest walls possible. At the same time, this doesn't mean you have to go overboard with everything else like I did with the finishing, for example. And it's actually with the interior finishing where you can achieve the most savings. Because I built the weather-tight shell of my house for 1.3 million, but the total expenses have already exceeded 5 million. From my experience, I realized that since walls are so important, you shouldn't try to save money during key construction stages. And it's better not to buy toilets for 40,000 like I did, but to make the house's load-bearing structure and building envelope as good as possible. Everything else is easy to replace or fix. We've established the importance of walls, but now the question is, what counts as the thickest walls possible? I visited the Open Village private housing exhibition this year, where almost all possible construction technologies were presented. I was really interested in poking at the sheets of plastic, and I already knew about CLT panels before the exhibition, but the massive Holzmauer technology was new to me. And this is already a good option for those who are looking for a real wooden house, not a house made of insulation. Another new thing for me was the smart block technology. This isn't a new technology. Houses like this have existed in Europe and the US for years, but I personally knew nothing about it. As someone who lived in a wooden house for years, my parents had one, I realized I don't want that for myself. I want a stone house. And you can hardly call a house made of aerated concrete blocks a stone house, so I was really interested in taking a closer look at the smart block technology from two perspectives. First of all, as they say, it doesn't hurt to dream. I walked around the show house and dreamed, What if I had a stack of money and wanted a nice turnkey house for myself? That's pretty clear overall. I actually recorded a separate video reviewing a finished house built to the Next 125 design, and I'll leave a link in the description. Secondly, I like to look at everything from the perspective of a self-builder, and I managed to visit a construction site and see how everything happens in real life, and that's where things get more interesting. Smart block is, roughly speaking, a permanent formwork in the shape of molded concrete blocks. They're manufactured at a factory and delivered to the site on pallets just like any other material. The blocks can have different thicknesses and shapes depending on the task at hand. For example, the blocks can be used for walls or they can be foundation blocks. The first row of wall blocks is placed on a cement sand mix to level foundation height differences and ensure perfect horizontality. After that, the blocks are laid using tile adhesive with a thin joint, and the vertical joints are made dry without mortar. Between the rows, 8mm rebar is placed in specially designed grooves. The same rebar is placed vertically with extensions for overlapping and tying in the next masonry rows. To lay the blocks with staggered joints, some of them need to be cut. This is done with an angle grinder and the appropriate disc. The cut blocks at the ends of the openings are then coated with mortar. In this way, 5 rows are assembled. A small crew can lay 23 rows in a day. Each block weighs about 16 kilos. This is even less than a 300 by 300 D300 block which weighs 17 kilo when dry but usually arrives wet and actually weighs 20 kilo. You don't need any special skills to do the masonry. So technically, you can handle laying the blocks on your own, single-handedly. Where it will be more difficult is when pouring the concrete, since you need to fill all the space inside the blocks. Theoretically, you can do this yourself with a concrete mixer and allow for a few cold joints. But this already borders on my favorite mix of stupidity and bravery, which has little to do with quality construction. So, in an ideal world, it's better to pour using a concrete pump, and there are options here too. You can pour concrete into a container and use buckets to fill the walls or pour it directly from the pump hose. The second option is more preferable, but here we run into real life again. Even in St. Petersburg, it's hard to find a concrete pump that can deliver the mix carefully, meaning not too fast. When the concrete is delivered quickly, it gets very messy, there's a lot of waste, the walls get dirty, and it doesn't even look very professional. There are pumps out there that can do everything neatly, but where can you find them? Nobody knows. I wasn't building in St. Petersburg but in the Leningrad region, and here hardly anyone has even heard of a concrete pump. And I ordered it from St. Petersburg, paying for delivery over 120 kilometers. I had to order the concrete mixer truck and the concrete pump separately. There was no other option. I was looking for a pump and mixer truck. Thought it would be cheaper that way, but it turned out it wasn't. Not cheaper. Today, ordering such a thing costs 24,000. But from my own experience, I can say that it's worth it. Unfortunately, not everyone even has the technical ability to find a concrete pump, but that's not a big problem. Literally 3 to 4 people can pour the walls of a typical 100 square meter house with buckets in about 4 hours. An important detail is that the mix absolutely needs to be vibrated. I rented a concrete vibrator for my construction site, but actually they don't cost much. During the pouring process, I watched the joints in the block masonry, and to my surprise, the cement slurry didn't even leak out of the empty vertical joints. There were just a few minor local leaks on the walls which you can easily ignore. In 3 to 4 pours depending on ceiling height, all the house walls are raised. And even for a self-builder, it's quite realistic to assemble an almost monolithic house. Besides the construction technology, I'm also interested in finding the perfect house layout. And I tried to imagine myself living in the next series houses, about which I managed to learn more, so to speak, firsthand. With us is Pavel, the head of SmartStroy company, and I have a couple of questions for him. You also posted questions in the comments on the Open Village exhibition video, and I'll ask those to Pavel too. Regarding the house layouts, many people had questions saying they didn't like something, or that the entryway is too small. Personally, for example, I have a couple of ideas on how to improve it. There were also some comments about the bathroom. People didn't really like that it's very long and narrow, like a corridor. As far as I understand, there's an option to move something around if someone needs it, because as I understand it, we have 5 load-bearing walls.
Yes, that's 5 walls, meaning the perimeter and a central load-bearing wall. Basically, it's an open layout, and even in the load-bearing wall, you can make some openings. So all the partitions can be moved, so that's not a problem. The architecture of the next 72 and next 94 houses was designed by the well-known architect Oleg Carlson. And as he always says, if someone doesn't like the houses, it means you have no taste. And taste needs to be developed. In my opinion, the houses are interesting. I mean, they are interesting from an architectural point of view. I mean, we're different from others because all of these, well, are boxy little houses. Honestly, a lot of people are already pretty tired of them. We want something more original, And here this concept is carried through here. So if you're a brave person ready, let's say, to experiment a bit in life, then basically you can consider this house. If you're a conservative person, then, well, yes, something like that, yes. Here, this is exactly a house from the 90s, yes, a frame house. This roof, yes, like that. And about the layouts. I actually wanted to say that the layout of any house, well, unless it's a house of 1,000 square meters, is always a kind of compromise. It's a compromise between your wishes and what the architecture and geometry allow. So the next projects here are just the way they are, yes. That is, the layouts we present, well, we consider them the most optimal. Of course, some people might change them, but there are other projects as well. So, it's not necessary to order this particular project. If someone likes it, and many people do, they order it. If someone doesn't like it, they order other projects.
And you can make changes, like modify the next a little bit, just like we saw earlier today, a house built according to a completely individual project.
Yes, of course. Actually, we have more than 150 projects on our website, and there are even more that aren't listed online, and we can also develop a custom project.
As for construction technologies, I actually first heard about you, among other things, from Sergei Petrusha, who talked about houses where tilt-up is used. If I understand correctly, reinforced concrete panels are cast on site and then assembled with a crane. Is construction still ongoing using this technology?
If I'm not mistaken, yes, it continues, and here in St. Petersburg there's even a project like that. It's Olgina. It was built using this exact technology because in St. Petersburg it's not convenient for everyone to bring blocks from the Moscow region. It's quite expensive.
Is your production only there currently?
For now, only in Shelkovo, yes, that's Shelkovo in the Moscow region. But if there is demand, we also plan to open a factory, a production line for these blocks in St. Petersburg.
What's the price difference between tilt-up and smart block?
And if we're talking about the standard floor height without deviating from the project, then they're the same.
And about the smart block at the exhibition, I tried to talk to the guys there about it. They gave me a reference point that if an aerated concrete block costs 8,000 per cubic meter, then the smart block should be comparable.
Overall, yes. So if we're talking about a finished structure with facades, with some specific ones, for example, with plaster facades, then more or less the price per square meter ends up being about the same.
There were a lot of comments, including from me, about the corner windows. Both my wife and I feel that the upper part is okay, but the lower part is not okay.
Let me comment on that, yes. Actually, what do we get? We kind of have a floor-to-ceiling window, but in addition we get a windowsill. A windowsill where we can put flowers, a phone, charge it, and so on. We could remove this part, but I think it would make things duller and less bright. It's theoretically possible to make a floor-to-ceiling window without this crossbar, but in practice there are some technical nuances, because our windows, well, double-glazed units are usually manufactured uneven anyway, and when you make this joint out of two uneven double-glazed units, it turns out to be...
The more deviations you get.
Yes, there can be some nuances, and the crane accordingly is needed for installing these windows, but here you can install them manually.
But at Open Village, the window was incredible.
They installed it with a crane, yes. They used a crane to install it, but that was the only window there.
Such a huge window, damn. And we also noticed that next to these corner ones, there are also regular narrow-framed windows.
In every room, let's put it this way, well, based on our own principles, according to safety requirements, yes, so that there's an emergency exit. Yes, an emergency exit and emergency ventilation. So, God forbid if there's a fire in the house or the ventilation system shuts down, although we always, we never offer these houses without a supply or supply and exhaust ventilation system. That is, it must be there and it must work around the clock. So, if it suddenly breaks down, for some reason, like if the power goes out, for example, then we can open a window and air out the room.
I thought about frameless glazing for my own house too, but I simply didn't have the money to experiment. It was very interesting to see it in person, and I'd think twice about whether it's worth it. The thing is, in a perfect world, everything looks great on the drawings, but in the real world on the construction site, you often come across defective glass units. For example, there was an entire waterfall inside the unit. I had a cracked glass unit at home replaced under warranty myself, and from a regular frame it can be taken out and replaced in 5 minutes, but with frameless glazing the finishing is tied to the glass unit. And in case of an emergency, to replace the unit inside the house, you'll have to remove the window reveals. So basically, this is the edge of the slab, meaning our wall goes here and ends right here. Here's the waterproofing under the blocks. This is an external mounting system, so it goes beyond the wall like this, using wooden beams. You can do this with a Triotherm profile, but that's really for people with money, and honestly, I couldn't find Triotherm anywhere. You could only buy it in Moscow, at least when I was building, and now that foam board basically serves as insulation for the foundation on that side. Everyone's interested in the money. As far as I understand, the price for what I saw at the exhibition is around 20 million.
Yes, the next 125 costs about 20 million turnkey, meaning that's already with plumbing and finished surfaces, but without furniture. That's the next 72 behind us, and it's cheaper. I can't remember the exact price now.
It's calculated per square meter. To give you an idea, it's about 140,000 per square meter.
Well, probably around 150 for a ready-to-finish state.
With the new season coming, it'll be a bit more expensive.
Yeah. In short,
you should expect it to be around 150.
Yeah, here it's the next two with an extension, meaning the client first planned the house and then decided to add the extension later. And now the time has come, and he chose to build the extension.
There's something I was also told, that my house has a gable roof with large overhangs, which really helps during rain and makes living more comfortable and the facades more durable, because my walls don't get wet at all. And when I go out of the house, I can step onto the porch in my socks even during a heavy rain thanks to the large roof overhangs. Does this have a destructive effect or not?
Well, actually, this decorative plaster is designed to withstand precipitation, so there's no problem with that at all. This is a silicate silicone compound, and basically there are no problems with it. Moreover, in some cases, even rain helps to wash the facade. Yes, because not all of our clients wash it themselves. Actually, this should be done once a year, yes, and it's done with a pressure washer, that's it. But not all clients do this, so particles of pollen can get stuck on the facade and some dust as well, and then it all starts to bloom, turn green, and so on. That's why in this case, when we don't have eaves, the rain helps to wash it off a little bit at least. So from the point of view of durability, well, there aren't really any...
If you use good material, then everything will be fine.
Yes, use good materials.
Continuing, let's get back to everyone's favorite topic, walls. I had to choose what to build my own house out of too. Initially, I preferred a frame house because I was worried I couldn't manage one made of aerated concrete blocks.
No.
It looked daunting, but I got it done. Suppose someone wants to build a house, but instead of choosing between a frame house or aerated concrete, they're considering aerated concrete and smart block. So what should make him choose smart block?
It's a pretty serious topic, actually. If we're talking about comparing frame houses and masonry houses, their cost is almost the same. Savings in frame houses can be achieved in two ways. First, it's savings on the foundation, if we have piles and the floors are suspended, meaning we have wooden floors. And second, it's on the interior finishing. That is, if we don't do any high quality renovation, but just use some simple paneling, so that's how the savings are achieved. And that's actually why frame houses are always considered cheaper. But if a frame house is built on a proper foundation, on a monolithic concrete foundation with good finishing, then the cost is about the same, dollar for dollar, yes.
And with good interior finishing?
So the price is the same for a masonry house or a frame house. But if the frame house is also built with quality materials, then yes.
Precision cut lumber, good insulation, film, good tapes.
That's right, yes. And proper roofing as well, proper roof construction. Now we start comparing an aerated concrete house and a house made of smart block. How do they actually differ from each other? Aerated concrete does not require external insulation. That is, aerated concrete is a material that combines two functions. It is both load-bearing and insulating. We have our block of a certain thickness, which has certain properties provided by the manufacturer, and we have to build with it. So we have a certain thickness, a certain thermal resistance. Accordingly, we build a house out of it, and we end up with some kind of house. If we're talking about smart block, then smart block is a material that's purely structural, load-bearing. That is, we use it to make the load-bearing structure, and then we insulate it with the layer of insulation we need.
Depending on each region, we can choose what we need.
Yes, so it depends on the region, the cost of the heating source, and so on. If it's smart block, it also depends on the customer. on the customer's preferences and the energy efficiency requirements. So for example, if we heat a house with electricity, we have found through experience that basically any reasonable layer of insulation pays off in a reasonable time within about 7 years. That 300 millimeters isn't there for nothing, they also pay off. So if we take a house, for example, and insulate it with 200 Mi or say 300 Mi, those extra 100 Mi will pay off within about 7 years if you heat with electricity. And this is a very important parameter, so when choosing the thickness of the insulation, we should be guided by the cost of the heating source. If we still insulate our concrete wall, it turns out that all our concrete, the entire concrete wall, is in the warm zone. That is, its entire mass is heated up to almost room temperature. Because of this, we get very high thermal inertia in our house. Not the wall structure, but the house itself, yes. So here we're saying that if, for example, for some reason the electricity goes out, or the boiler shuts off or breaks down, or something else happens, our house will take a very long time to cool down. Because the thermal inertia of the whole house is very high due to the warm mass of the walls. In a frame house, as we know, it cools down by the evening and you can't stay in it anymore. That's why for permanent residents, from a safety point of view, it makes sense to consider masonry houses built from heavy materials. Well, besides that, smart block, the wall structure made of smart block, it doesn't have any shrinkage at all. Because it's already dry, you know, from the factory and already compressed, yeah. So the concrete itself doesn't shrink anymore, it doesn't have much moisture. Basically any concrete structure is considered dry a month after pouring. That means it's ready for finishing. Right, and also the strength. Strength, that is earthquake resistance. Maybe not many people need to know this now, but in seismic areas...
Yes, as far as I understand.
In seismic areas, yes. I just didn't mention it because after all it's quite far to transport from our production to seismic areas. That's it. But nevertheless, if we ever open something somewhere in the Krasnodar region...
Krasnodar region?
Yes, besides, yes, then in principle it's very relevant there. Because there everyone builds these monolithic columns, then infill between them with shell rock or, more recently, aerated concrete. So accordingly, cracks always form in these joints, and all this work takes a lot of time. Accordingly, here we just build the wall faster and it's already earthquake resistant. So that's why there are actually quite a lot of advantages. If we talk about the difficulty of building the walls, it's only slightly more complicated. I mean, it's just about pouring, well...
I just looked at it now, and yes, basically it's all doable. There's nothing like any space-age technology involved.
This job doesn't require a high level of skill for pouring. That is, unlike, for example, a frame wall, where you have to keep a close eye on everyone, how they glue all those membranes, how they lay the insulation so that everything is tight and neat, and to make sure the frame is straight. Here, well, that's not required. So you build the wall, check if the rebar is there, everything is fine, pour the concrete, vibrate it, and that's it. Pouring and vibrating can be done by any worker, regardless of skill level, who is able to lift a bucket of concrete.
As a self-builder, I also noted for myself that with smart blocks, there will be fewer issues with cracks. For houses built with aerated concrete blocks, it's best to wait a few years before plastering the facade. I used a special crack-resistant plaster, but it still cracked in the 3rd year. I also had to deal with high humidity inside the freshly built structure. I even had to rent an industrial dehumidifier to prevent everything inside from getting moldy. That shouldn't happen with smart blocks. If you dig deeper, you'll definitely find some more nuances. With the permanent formwork technology, you can really get a house with better overall performance, and at a comparable price to a house made of aerated concrete blocks. Will it be harder for a self-builder? Yes, definitely harder. You won't be able to cut chases with a drill driver anymore. You also won't be able to cut doorways with a handsaw. And all those other tricks we love so much won't work either. But maybe the result will be worth it. I'm not urging anyone to do anything. I'm making this video purely for informational purposes, because I was genuinely curious to get hands-on with all of this myself. And a huge thanks to Pavel for this opportunity. I hope I was helpful to you. I have a couple more interesting stories for you, so subscribe to the channel so you don't miss them. Write in the comments what you think about all of this. As it turns out, not only do I read the comments, but so do the heads of construction companies, so be sure to give your feedback. I wish you all warm and reliable walls. See you in the next video.